Meeting is being recorded.
All right, so I think it's recording right now. Okay, once again, thanks for joining this session. Good morning, everyone. My name is Ravi Saraswati. So today I'm in Houston, Texas office. I'm in the IBM office of Texas. I'm originally located in Virginia, Dallas, Virginia. I've traveled here for a project today. Is there anybody who's from Texas here? No one? Okay, so this is a second session for fundamentals of Kubernetes. So the last session was attended around like 120 people. So there was a huge crowd on the last session. So is there anyone here who did not attend the last session? Was everyone who attended, everyone in this call today is already attended the last session?
Hi, Ravi. It's Mike Davis. I didn't miss the first one, but I'm somewhat familiar with this topic, so I should be fine.
Okay, great. Hey, Mike. Yeah, I think we'll take like 5 minutes to go through the details of the last session. You can let me know if any questions related to that. So a couple of things. Please mute your microphone and please feel free to ask questions anytime. I want this to be an interactive session rather than me talking all the time. Please note that this is a fundamental class, right? Fundamentals about Kubernetes and Docker. Please let me know if you're interested in participating in the advanced class for this, or you want me to conduct another session for the same. I'm planning to schedule an advanced Kubernetes in the first quarter of next year. So let's see like what we talked last time. We talked about last time the containers, right? Why are we caring about containers? What is a container? And how to create a containers. And we went through a brief demo also, right? And today we will talk about Kubernetes, right? Why we need Kubernetes and what is a Kubernetes? And we'll do a short demo for the Kubernetes that is available in Openshift, AWS, Google, Azure. We'll see how Kubernetes being available in these cloud providers. So last session, I'll take a couple of selective slides from the last session. I will not go through the entire slides. It takes like a lot of time. So last session, we talked about the different architectural models available right now. Right? We all know that the enterprises are going through the digital transformation journey. Right? The digital transformation drives changes in transforming the customer experience and the operational process, and also making the changes in the business and culture changes. So the old model for the three-tier architecture model, that's not applicable anymore, right? We need to utilize new architecture models in the cloud era. We also talked about why containers, right? Why people should care about containers. What's the advantage of a containers, right? We said that containers enable the microservices architecture. That means instead of creating a monolithic application, you can create multiple services for an application, and each of the services can be managed by different development team, have different deployment model, and using different programming languages, right? For example, for a shopping cart applications, for a e-commerce applications, you can split that application to multiple services, such as shopping cart, such as customer experience, such as checkout, and each of them can be managed by different teams, done by different programming languages, different deployment process. So the containers enable that model, right? And also you can port your application from the developer application, from the developer desktop to all the way to the production without making any changes. So we talked about a couple of advantages of why we should care about containers and why are we people talking about containers. It runs in physical servers, in any cloud providers, it doesn't matter. Okay. Then we talked about what is a container, right? We said containers is nothing but it's a software package. It encapsulates all the dependencies for the applications as a one package. See, I stopped downloading the software to my laptop, right? I always download the software as a container. That means everything, all the dependencies are available as a single unit. There is no more files scattered across multiple library folders and multiple places. We also talked about what's the difference between a container and a VM. Right? So how to create a container? So we talked about why we should care about containers. We talked about what is a container, and we are talking about how to create a container. So we said there are 3 steps for creating the containers. One step is creating a Docker file, and you build an image out of a Docker file. Or you download an image from Docker Hub or any of the registries that is available. And then you execute the Docker run command, and that is how you create a container. Let me take a look at real quick. So if you look at here, can everyone see my screen?
Yes, Ravi.
Okay, great. So if you look at here, right, so this is let me clear it. So all you need to do is, if you want to create a containers, all you need to do is just download Docker software or Cryo software. There are different software available that will enable you to create a containers. So once you download and install that software in your laptop, basically you can start creating containers and you can start running the containers on your laptop. For example, I downloaded Docker here. So if you look at here, these are the Docker commands available for me to utilize. So we can utilize different Docker commands in order to start creating the containers and manage the containers. For example, if I say Docker images, these are the images that is available right now in my laptop. You can have these images directly download from Docker Hub. So what is a Docker Hub? So Docker Hub is a public container registry that people can create the containers and upload it to the Docker registry, Docker Hub. And all the people can download that containers from that Docker Hub. For example, like IBM, right? Look at our company. We have a lot of software. We made it available in Docker Hub. That means people can download IBM software directly from Docker Hub and start utilizing for their purpose. So this is a public registry, right? But you may not want to make all your containers that you're creating for your enterprise application, you may not want to make it available in Docker Hub. So what is the alternative? So we don't want to store the containers into the Docker Hub. Why? Because it is publicly available, right? Anybody should be able to download it. So we wanted to make it available in a enterprise registry. That is why we have different registry products available, right? If you look at here, we have Artifactory available, Red Hat curl available. We have a lot of container public providers are providing different container registry. So we have one public container registry that we put all the containers that is available for public, and we have an enterprise registry that we store in our company that we need to keep it for our own purpose. So going back to this stuff, so how do we create a container? We said like 3 steps. We said first step is Docker file, or we create download from Docker registry. So let's look at the Docker file available. This is just a simple command from Java. That means it's downloaded from Docker Hub, a container called Java, and it runs a command called Java. So if you look at here, if I want to run it, all I need to do is Docker run and review Java. And so it will execute that particular image and it will start creating the containers. And if you look at Docker PS -a, I think it will tell you all the available containers running in your laptop. So that's all about containers. I don't want to spend any more time on the containers, but let me pause here. If anybody has any questions about containers? We haven't talked about Kubernetes yet. We just talked about containers alone.
So I have a question actually.
Yeah.
So usually we have some kind of software in the container and we can directly use it for our, let's say for example, if we want to make an e-commerce website and we already have like cart and login. So is it something like we just plug and play the containers in a source code or how it works?
Yeah, so you need to, so it doesn't matter what programming language you're utilizing, right? Once you create your application, you need to encapsulate that as a container using the container applications available, right? Once you create it as a container, then you can basically run that particular software. It can be an application, it can be a software, or it can be a legacy product. It doesn't matter. You can encapsulate all these things as a containers and you can run it. Will all the applications available today, is it make sense to run it as a container? Absolutely not. There are certain use cases available. That's the job of an architect, right? When an architect wanted to create an application or they wanted to enhance an application, they have a decision. Okay, it is running in on-premises. Now I wanted to run it in the public cloud or some other places. Do I need to do a rehosting, just lift and shift, or do I need to do a refactoring? That means I'm converting this application to a microservices architecture that enable us to run it in multiple containers and use an orchestration engine. So we have to take case-by-case approach, right? But right now, if any new applications that I'm creating it, I will seriously consider utilizing container for my purpose.
Thank you.
Okay. Any other questions?
Yeah, I have a question, Deb here. Can multiple process of any any software can be run in a container? And as I understand, container is it runs a specific process, and once the process dies, the container also dies. Is it correct statement?
Absolutely. If you look at here, when I do a Docker PS -a, nothing is up and running. You're absolutely right. That's the beauty of a container, right? It doesn't take your CPU power or memory power. It runs only on as needed basis. That means in my Docker file, all I put here is from Java, command Java version. That means once it's executed the command, it's exited out of it. It's done, right? It's not up and running anymore, right? If you want to make containers up and running all the time, that means you need to tell containers to do some processing all the time, right? You don't need to run all the time. That is the computation, right? That's a shift of mindset. Do I need to run the application all the time in order to get a certain results, or shall I execute it and get my results and get out of it? That's why we have the event-driven serverless model right now that is very popular. That means I'm not running anything. In my computer, nothing is up and running. It will start running when there is an event coming to my system. Then immediately the containers or some functions will wake up and start doing the processing. And once that processing is complete, it ends, right? That's why the event-driven model, the serverless architecture, like AWS, we have Lambda. Azure has something, Google has, a serverless function, IBM has it. So the serverless function, that is why it is very popular. It required less computation purpose, less memory. Okay, anything else? Any other questions? Okay. All right, so let me go to the Kubernetes. So we talked about containers, right? It encapsulates all the dependencies, and you can port your application from laptop all the way to production without making any changes. You can run it in all the bare metal servers. You can run it in multiple public providers without making any changes to the application. So why Kubernetes? So we have these containers. Why are we talking about Kubernetes right now? Why we wanted to make our life complex, right? So one of the issue, I think somebody just asked the last question. He said, yeah, the containers are a process. It runs in a computer. You're absolutely right. Containers is a process. That means that process can die anytime. So one of the major issue is applications goes down in the production. We need to restart the VM. We need to restart the application all the time in order to make sure that it is up and running because it may stop responding. So the Kubernetes, what it does is it manages the containers and it ensures that these containers are running all the time. That's one of the features Kubernetes is providing. So it provides a container orchestration. That means you are creating a containers and you are running it in one host, but you wanted to run these containers in multiple hosts, providing the load balancing features, providing the failover capabilities. So the Kubernetes provide the container orchestration and enable us to run these containers in multiple hosts. So what are the other benefits it provides? It provides a lot of benefits, right? For example, you are able to automate the deployment. It does the auto scaling. I don't want to go through all these things. What I really suggest is go to kubernetes.io. It's a very good site. It will provide you a lot of details. What are the capabilities? What are the features the Kubernetes provide? So what is the business value? I think we from the IBM, we should be able to convince or we should be able to talk in the customer's language why containers are important for them. So different organizations within IT has different priorities. So we should be able to talk in their language and say why containers are important or not important. So again, what are the types of Kubernetes available? Red Hat Openshift. This is our flagship products, right? We are promoting Red Hat Openshift right now. This is an enterprise capable Kubernetes engine that is available to utilize for the internet, for the enterprises. What's the difference between Openshift and all the other container right now? Because Openshift provides an end-to-end capability for enterprises. For example, Azure AKS. It provides just the capability for the container orchestration. It doesn't provide the ability to do a code checking, ability to extract the code from a repository, ability to scan the images, ability to do a continuous integration, continuous deployment process into the Kubernetes. So that's the value Openshift is providing. Do you guys familiar with these Openshift products? Is there any question related to any of these Openshift products? Let's take a look at a couple of these products. If you look at here, so this is somebody is asking a question? Okay, so this is an IBM Cloud, right? IBM Cloud, if you really look at IBM Cloud, cloud.ibm.com, we all have access to IBM Cloud. We have the Openshift right now. So we can go there to the Openshift and start creating the clusters over there. And this is a GUI driven. I highly recommend to start utilizing the OC, basically the command line utilities, because you can bring it up, you can bring it down. You know which application you are creating. All these benefits are available. So this is the IBM Cloud. You can log into IBM Cloud and create a Kubernetes engine, and you can start accessing that Kubernetes engine. This is a Google Cloud. You can see the Google Cloud platform, and you can see the Kubernetes engine here. And you can start creating the clusters in Google Cloud as well, right? And it will provide you, I think they give you like 2 hours free. You should shut down your Kubernetes engine after 2 hours, otherwise your credit card will get charged. I got burned a couple of times. Then there is another Kubernetes engine that is available from Azure. If you look at Microsoft Azure, this is the Azure console. They provide you the AKS capabilities. So if you look at AKS, search for AKS, that is the Azure Kubernetes engine. So this will provide you the capability to create a Kubernetes engine. You can just, click on GUI and start creating the Kubernetes engine. Again, I don't recommend anyone to utilize this GUI to create a Kubernetes engine, right, or Kubernetes clusters. You always need to utilize the command line scripts. In the case of AKS, you can utilize PowerShell, right? That is their command line utility. And our Openshift, right? Openshift has a Kubernetes engine. That is our product that provides the enterprise capabilities. And this is the Openshift console. You can start creating a project. You can run multiple ports and nodes here. We'll come back and we'll talk about this. AWS, you can go to AWS and there are different products. If you look at EKS, that is one of the Kubernetes engine AWS is providing. Other one is ECS, that is another engine, or a software as a service for Fargate. That is another product AWS is offering. So let's look at, coming back to this slide. So there are different products available, right? I mean, I think you can always go ahead and download this Kubernetes engines and you can experience the difference between Kubernetes, and that's how you will appreciate how good the Openshift is for the enterprises, right? If you want to create a simple container, you want to test it, you wanted to learn it, I highly recommend Minikube, right? I download Minikube in my laptop. This is an open source product. It doesn't provide you multiple nodes, but it will provide you one node and you can start experimenting it. So if you want to learn it, Minikube is a good idea. If you want to utilize a container orchestration for the enterprise, Openshift is a good idea. Okay, any questions? Okay. Yeah, go ahead.
So how it is making sense, like Kubernetes and products?
Can you please speak up? I can hardly hear you.
Can you hear me now?
Yes.
So how it is making Kubernetes? There are like products under that.
I'm sorry, I didn't hear your question. Can you please repeat it?
What I'm saying is like we are talking about Kubernetes, right?
Yeah.
So then there is Red Hat, Openshift, and other vendors. So how it is like?
How it is different?
How it is? Yeah, I mean, it is Kubernetes doesn't have its own thing like where we can. We have
See,
to be dependent
okay.
on one of these vendors.
So let's look at the history of Kubernetes, right? The Google, they were utilizing Kubernetes to orchestrate the containers. They were utilizing it, The Kubernetes is the core engine Google is utilizing to run many of their products. And what they did is they open sourced these products and they created an organization called Kubernetes.io, right? All the public cloud providers and a lot of people were part of that group. And Google, what they were doing is they created this utilizing the Go language. Even I am a contributor to that particular organization. So the Go language is what Kubernetes was written. So they made it open source, and once they made it open source, a lot of enterprises learned the value of this Kubernetes and they started utilizing it, right? And for example, like Red Hat realized the value. The model Red Hat is utilizing is, for example, like CentOS. They made a big business out of CentOS product, right? We have the RFCL. Similarly, Red Hat took that Kubernetes open source and they create an enterprise-ready product called Openshift. And a lot of enterprises start utilizing that Openshift for the container orchestration. At the same time, a lot of the public providers, like AWS is very late in the journey, right? Google was the first company who put the Kubernetes engine in their Google Cloud and empowered people to create containers and orchestrate that containers using Kubernetes engine. Google was the first public providers in this market. Then Azure followed, then AWS followed, and then IBM followed in between. So a lot of companies start creating business out of it. In that case, VMware jumped in. They started creating Pivotal Cloud Foundry. They integrated this with Kubernetes. So right now, we have an open source version of Kubernetes that's called Kubernetes.io. They have the latest and greatest version. That's what I showed earlier. If you look at Kubernetes, this is the Kubernetes open source, like Kubernetes.io. They have all the latest and greatest versions. All these vendors, they are taking the latest available version from this Kubernetes.io and they are making changes to that and they are start, marketing to the consumers. That's how it is working right now. But some of the companies like Openshift, we went far ahead than the Kubernetes.io, right? We are not using kube control, we are using OC. There are a lot of differences available between these implementations. But to answer your question, yes, the Openshift Kubernetes.io is the base product that is open source. If you wanted to contribute to Kubernetes open source, go ahead and do the Kubernetes.io. Red Hat also have an open source version. So that's where we are right now. Okay, any other questions?
Thank you, Ravi.
Okay, sure. Okay, so what exactly is a Kubernetes? Kubernetes provide the container orchestration, right? We said we don't need Kubernetes to run container. We can just utilize Docker and create containers and roll it out. Why do we need Kubernetes? When we want to run containers in multiple hosts. So that means container orchestration. So what is a container orchestration? What does it mean? It means you can utilize this software to deploy and configure. It will self-heal it. It will automatically auto-scale up and down. So what it provides? It provides the end-to-end capabilities, right? It provides, from build, test, deploy. So what is the concept of a Kubernetes, right? So let's go to the demo right now. Okay, thought I had another. Okay, yes. So this is where, let me clear it. Okay, make sure that this is running. Okay, this is running. So what I did is I downloaded the Google CLI to my desktop. That means I can run all the commands here, and that will directly connect to Google Cloud, where I have a Kubernetes engine up and running, that means I can interact from my laptop to Google Kubernetes engine. So let's go through a couple of slides, then we'll come back and we'll talk about it. So what is the basic concept of a Kubernetes? Does anybody want to explain this? So what are the basic concepts? What are the basic artifacts of a Kubernetes? We know that we have containers. So the way they organized is multiple containers can run in a pod. So pod encapsulate multiple containers. And then a artifact called node that will encapsulate all the pods. And this node can run in a virtual machine or a bare metal machine. So in a bare metal machine, you can run multiple nodes. So this is a basic concept for the Kubernetes, how Kubernetes organized. So they organized multiple containers in a pod, multiple pod runs in a node. This node can run in a virtual machine or it can run in a bare metal machine. And then you have multiple nodes in a bare metal server. So if you look at here, let's see. By the way, I'm using a command called kubectl, kubectl or kubectl. This is a command line tool, very similar to Docker. This is a command line tool to interact with the Google Kubernetes engine, or in Openshift, you can utilize OC. So when I'm saying kubectl get nodes, you will see like what are the nodes which is running in this Kubernetes. So how many nodes are running here in this Kubernetes?
Like 2 nodes.
I'm sorry, 2 nodes? Yeah, so we have 2 nodes running in this Kubernetes. You can create multiple nodes in a Kubernetes. So what is a node? That is how you encapsulate all the containers in a node. So the advantage of this concept is this node can go down, it doesn't matter, or a pod within a node can go down, it doesn't matter. Kubernetes engine will automatically bring that up. We'll see a couple of examples. Okay, we talked about a node and we talked about so how they classify nodes within the Kubernetes. They have a master node and then they have worker nodes. What's the difference between master node and worker node?
So is it like an open question?
Yeah, go ahead. Please make it interactive. I want you guys to help me rather than me talking here. I know a lot of people knows about this concept, so please go ahead and talk.
So worker node are something that carry out operation, but they need to be like controlled by a master, and the master is responsible for communicating with the nodes with the help of the APIs. They have like schedulers. They schedule which node should be activated, replicated, or deleted. They basically get the current state of a worker node to a desired state that the architect or programmer wants it to be in, and in an automated way, an orchestrated way.
All right. Thank you, Akash. Absolutely. Yeah. The master node is responsible for managing all the worker nodes. So where exactly your application running? Your applications are running in worker nodes. Your applications won't be running in master node. Master node is utilizing only for the controlling those worker nodes. So why am I not seeing a master node here in the Google command? So I install Google Kubernetes engine. I'm communicating to Google Kubernetes engine, and I'm seeing kubectl get nodes. I couldn't see any master node here. I can see only the 2 worker nodes. Why?
One of the reason is there can be multiple worker nodes, whereas there's only one master node who is responsible for orchestrating other nodes.
Yes. So all these public providers like Google, AWS, Openshift as a service, a lot of these Kubernetes engine providers, they control the master node. That is the control plane. They wanted to ensure that this master node up and running all the time, right? Because that is a control plane. Your application runs in worker nodes, so all you care about is worker nodes. You don't need to care about master node. So there are a lot of development happening. For example, like AWS. In my earlier company, we were implementing this, and then we realized AWS is not providing the compliance or auditing logs or security logs for the master node because it's a multi-tenant, multiple companies were utilizing it. And our security team said, absolutely a big no. I wanted to know what is the compliance and access that's happening in my Kubernetes engine that is logged in master node. So what they did is they implemented a process so that we can collect the logs from the master node. Same features available in AWS also. So the master node, what are the components the master node consists of? I think Akash mentioned about scheduler, control manager, API servers, and they have an etcd. This is a small like time series database that is available to store the sessions. So the master node is what is managing multiple worker nodes, and the way they are communicating is through the proxies and kubelets. I don't want to go too much details on this. I think we'll go through these details in the advanced class, but just to be aware that there is a master node and there are worker nodes. Master node is the control plane that is responsible for managing all the worker nodes. If any of these worker nodes goes down, the master node will go ahead and bring it up and ensure that it is up and running. So what's the difference between the open source version and our Openshift? Openshift has another node that's called infra nodes, right? This is basically specific to the Openshift. None of the other cloud providers, Kubernetes engine has it because we are doing completely an enterprise product, which consists of all the way from code repository to the deployment. We are providing image scanning capabilities. We are providing the registry capabilities. We are providing an ability to integrate this with the Jenkins and other ServiceNow and other providers. That's the difference between Openshift and other providers. We'll go in details later in the advanced class. So what is the Kubernetes architecture? I think this diagram is very important. I find very useful, just not because I created this, but just because of understanding the entire architecture. We talked about multiple worker nodes, and this is where the application is running. We talked about master node, controlling these worker nodes to ensure that this is up and running. And what is this?
Command line.
This is the command line. That's what we were utilizing to communicate with the master node. I'm not communicating to the worker nodes. I'm communicating to the master node. And I can get into the worker nodes by utilizing the kube control commands, by always interact with the master node, and from the master node, it will connect to the worker nodes. And we have the GUI part also, which nobody cares, right? Everybody cares about the command line. So how do we expose the application that is running in the worker node to the outside world? That is where the load balancing comes. If you look at each of the public providers has different load balancers available. AWS has its own load balancers. Google has its own load balancers. and you associate with load balancing with a DNS server, and you expose this application to the internet. And there are different load balancing algorithms. There are different way of exposing this to the outside world. And nothing is made it available to the public unless you specify it, because otherwise it will be running accessible only through your internal company. For example, if you are using a Kubernetes and if you are putting an application in that containers, unless you associate with a DNS server and a public load balancer, it will not be accessible through the internet. We had an issue earlier in my earlier company. We installed the Kubernetes and we made it in the AWS. We created the log files, and we utilized Kibana. Kibana is one of the GUI that makes the log files available for the outside world. We call it as EFK stack, Elastic, Fluentd, and so a couple of software we utilize in order to collect the log files from the Kubernetes. So somebody created a Kibana GUI, but what they did is they exposed that Kibana URL to the outside world. That means the application is internal, but you are utilizing Kibana software to collect the log files and make it available through the internal company, but somehow it's exposed to the outside. That means entire outside world could see the log files. So the log files means they will come to know what is the Kubernetes master node IP address, what's the worker node IP address, and they get to know all the details. So please be careful when we play around this with Kubernetes, especially when you're exposing the log files. So once again, this is a high-level Kubernetes architecture: master node, worker nodes, kube control, command line option to interact with the master node, and expose this application through the load balancers and internet. Okay. So we can utilize kube's control for all the purpose, right? For example, you can come to know like kubectl get nodes, get ports, right? If I do that, right now there is no ports running because in the default namespace there is nothing. So just let me tell you this. Can anybody explain the namespaces concept within Kubernetes? What exactly is a namespace within the Kubernetes engine? You can segregate the Kubernetes to multiple areas. For example, like development, test, UAT, production. So one Kubernetes engine can have multiple environments, right? Is it a good idea to run it in an enterprise? May not be, right? In the enterprise, you have multiple Kubernetes installations. We have one for development, one for performance, one for productions, and then you utilize a CI/CD pipeline process in order to do the deployment and move the images from one environment to another environment. However, the Kubernetes itself provides the capability of segregating it as multiple namespaces. So these are the three namespaces I do have: default, kube public. So if I do kube control, get ports, all namespaces, I should be able to see all the ports that is running in each of the namespace. So this kube system, this is a default namespace created by Kubernetes, which is utilized for the Kubernetes engine. All these ports are default created by Kubernetes engine. We talk about, for example, like Fluentd. Fluentd is to collect the log files. Google Kubernetes engines automatically provides a Fluentd installation for you. So this will collect all the logs from the Kubernetes. But you can create your own namespace. For example, let me see that command here. Okay, so you can create your own namespace. For example, like I created a namespace called Ravi namespace. So I can see like kubectl get namespace. I can see that there is a namespace called Ravi namespace. So as a best practice, always create a namespace and then run the containers in your namespace. Never run the containers in a default namespace because it will get clogged. So how do I create a, so if I do a pod, get pod, I can get all the pods that is running. So how do I create a pod? So let's see, kubectl run, say nginx, so let me take the command. So if I do this, kubectl run nginx image nginx, what exactly this command is doing? So when I execute this command, run nginx image nginx, what it does is it goes to the Docker hub and download this nginx and start running these containers in my nodes. Now I can see this particular node is running. This particular pod is up and running in my Kubernetes, right? Again, I don't want to go through the details of all these kube control commands and creating the pods. I highly recommend go to the kube control command, and there are like different basic commands available: create, expose, basic commands, deploy. I'll leave this up to the advanced class to go through these commands and start creating the pods and all those stuff. Let's focus on the high level stuff. So what is the we talked about CI/CD deployment process within Kubernetes. That means you guys remember, like in the early 90s, we spent hours and hours for the deploying an application into the production. It is a sequential process. You have like operations, you have the DBAs, you have middleware admins, you have infra people, everybody coming together, and they all say like, did you made your change? Okay, they said they made a change, and it's a sequential approach. It takes hours to do a deployment of an application in production. Nowadays, the deployment happens every day without even shutting down the application, without even informing the business that we are doing a deployment, because now it's very advanced right now. Netflix, a lot of people put through the code all the time. So how is it possible? In my earlier company, we implemented a process for deploying a couple of applications. What we expect is developers taking the code to code repository and then commit it. That's it. We don't expect them to do anything. The entire process of the deployment is completely automated. That's the beauty of the containers. That's the beauty of the Kubernetes. So what happens? Developers commit the code to the Git repository, and then what happens? People utilize multiple ways of doing the CI/CD. I just documented one way, right? So developers check in the code to the code repository. Once they check in the code repository, Jenkins, it's listening to that. It will get triggered. And what happens when Jenkins gets triggered? Jenkins has a pipeline process, and that will create a container image and push it to the registry. There are different registries available. We have IBM registry. We have Red Hat QL, that is another registry. And different public providers have their own registry. And once they log in, push the images to the registry, then what happens? Another software, continuous delivery software like Spinnaker, it will be listening to that registry. Once it knows that, yes, there is something, it's there in the registry, it's particular folder, it will go ahead and it will push all these Docker images to the Kubernetes. And there are different deployment methods available, like blue-greens or like canary. That means it doesn't do the deployment for the entire application. It does the deployment for a service for either certain users or certain nodes. There are different deployment strategies available. We may not need to utilize Spinnaker. For example, Jenkins itself has the capability. We can write the pipeline process, pipeline commands in order to push the code directly to the Kubernetes. So you know that all we are expecting developers to do is to check in the code to the code repository. The entire process is completely automated. I didn't show all the process. It requires the ticketing process. Like, for example, it creates a ticket in ServiceNow with the approval. You can do that from the Jenkins. It has plugins available, or Spinnaker has plugins available. And you are storing it in the registry. You need a security scanning. There are different security scanning products that are available, right? There are like Artifactory registry. That's one of the registry products. It has a default security scanning software that you can configure this with. So in an enterprise, in order to do a deployment, you need to do maybe multiple approvals may be needed. Multiple security scanning is needed, making sure that there is no malicious software you are deploying. So all these processes you can completely automate and you can deploy. Now you see the benefit of the entire Kubernetes architecture. You can deploy it automatically. All we expect is developers to check in the code to the code repository. The entire process is completely automated. Any questions about this?
So one question, Ravi. So this Kubernetes in this particular diagram is used for test and test and QA, or it can be used as a production also.
It is meant for production.
Okay.
In production, there are additional steps involved in that. For example, create a ServiceNow ticket or some other ticket process, get the approval from another person, right? So you can customize it. See, different enterprises have different process and procedures and auditing and compliance requirements. So you need to be aware of those compliance requirements. And when we do the automation, we need to make sure that we meet those compliance requirements. Otherwise, we'll get into trouble, right? This is meant for production. A lot of applications are doing the deployment in this way. They don't expect anything other than a developer committing the code to a Git repository to a certain folder that's meant for production deployment. That's it. So again, since the application divide to multiple services, you are doing minor changes, incremental changes using Agile and DevOps process to a particular service. That means even if something wrong, it happens only for that particular service. Your application will be up and running, right? That's the beauty of the microservices architecture. You're splitting your application to multiple services, which is communicating through REST-based interfaces. That brings the agility, that brings the operational efficiency, that brings the digital transformation for a company. Those are the advantages.
Thank you.
Okay. Yeah. So let's take a quick exercise. I really want you guys' participation in this, right? So we talked about the Kubernetes-based application, right? And we have a traditional web applications with VM, right? We know a three-tier application, we call it as monolithic application, right? A three-tier application. What do we call it for Kubernetes-based applications? What are the new architecture models available that can create an application based on Kubernetes?
Is it microservice architecture?
There you go, sir. So simple. Thank you. So it is a microservices architecture. Again, you don't need Kubernetes to create a microservices. You can even create a microservices architecture by using Java. and invoke those Java applications using the REST-based interfaces or SOAP. Now nobody uses SOAP, but everybody is using SOAP. But it is much easier to utilize Kubernetes engine. So hardware with virtualization, right? We call it as any idea about what is a Kubernetes-based application? What we call it as containerization. Thank you, sir. We call it as operating system virtualization, right? So hardware, we are running hypervisor on top of hardware, and that is how we are creating multiple VMs. Now, we don't have multiple operating systems. We have hardware, and we have operating systems, and then we do have Docker engine or Cryo engine on top of it. That means we are not replicating operating systems. Operating systems are very heavy. Containers are very lightweight. You know why it is lightweight? Because you are not replicating the operating system. Virtualization by hypervisor. Containerization, right? That's a new word. We are not talking about, again, containers is a lightweight virtualization, but you don't need VMware, vSphere, or any other hypervisor engine in order to create lightweight containers in a bare metal servers. You don't need that. It is okay to have it. That will give you another abstraction layer, but you can create lightweight VMs or lightweight containers in a bare metal servers. So we call it as virtual machines or load balancers. What is the new model in the Kubernetes?
Orchestration.
Orchestration or containerization, or we call it as node, pod, services. In the Kubernetes world, we nobody call it as virtual machines, right? We call it as node. Node is nothing but a virtual machine. Pod is nothing but a process that is running inside the node. And then inside of a pod, we have multiple containers. And service is something like we are exposing to the outside world. So I think we are running out of time. I really don't want to go through the entire stuff, but you got the idea, right? I think the best way to learn this is to understand what we are doing right now and what need to be done in the new microservices Kubernetes world so that we can compare and contrast. For example, like service bus. Right now, nobody is using service bus in the new microservices in the cloud era, right? Everybody is talking about API gateway. That can be utilized in order to expose your application to the outside world. Nobody uses service bus. Or you utilize API gateway to extract the data, expose your data, right? Data as a service. There is no need of using ETL process to copy the data from one database to another database. You use an API gateway to expose your data so that all your application in your enterprises can utilize it. So let me pause here. We have a couple of slides, but I really don't want to go through the details of this. These are the additional concepts. For example, liveness probe to ensure that traffic is not going to their application unless the containers are ready. Readiness probe to ensure that the containers are up and running. Let me pause here. Is there any questions that I can answer? I think
Yeah,
we
Ravi,
only have 2 more minutes.
I have a question here, Ravi.
Yeah.
Can you hear me?
Yes.
There is a concept like real time. You just spoke about the merging or migrating a ticketing tool with the containerization or Docker, Kubernetes, the services and like microservices. So, which are two different entities completely. Something like Jira or maybe ServiceNow, supposed to be a huge ticketing system for a huge environment, something like a centralized server, a customization. And whereas here, we are doing it by using just a small lightweight plugins. So how widely we can customize it and how efficiently can work in a real time.
So how we can customize the containers?
Yeah, my containers with the ticketings, something like a service now for a ticketing for a customization containerization factor. When we're talking about the production deployment.
Yeah, so that is why you need to utilize, see, we can do a lot of things with by writing an application within containers, but I think as architects, we need to make sure that we utilize the right software for the right purpose. So for example, if you want to create a ServiceNow tickets during the deployment process for the containers, you utilize Jenkins or you utilize Pinnacle, right? Because that has plugins available to the ServiceNow or different ticketing systems that you can create tickets for your purpose, right? You may not want to utilize a custom application to create the tickets. Can you do that? Yes, you can do that. But there are software available that is out of the box that does that capability. So utilize the right products for the right purpose. So again, containers are not the answers for everything, right? So we need to be very careful. For example, if you want to create a small web application, which is utilized by 10 people, do I need microservices for that? No. Traditional simple Java application may be good, right? Okay. Any other questions?
No, Ravi, thank you. That's really great. Thank you very much.
I think we have 1 more minute, 1 more question. Is there anything else?
Ravi, it is not.
Can you please speak up?
Can you hear me now?
Yes, go ahead.
So I'm planning to take a certification, but I'm not sure whether it should be Docker or Kubernetes. So you have, can you give me some insight into that? I mean, which one will be better to go for, or
Yeah, I would
should it
highly
both?
recommend. Kubernetes has 2 certifications available, which is managed by Linux Foundation. One is CKAD and another one is CKA. You can do a Google search for CKAD. CKAD is for developers and CKA for the administrators. And this is very good certifications because this is really hands-on experience rather than like AWS certification like theory, right? This is I really like these certifications. If somebody says like I have a CKAD certifications, I always value that because they know it's not only theory, they know the practicals also. So just do a search for CKAD and CKA, you will get all the details. Okay?
Okay, thank you.
Okay, thank you. Thanks everyone for joining the call today. I'll share these slides. I don't know how to share with everyone, but I'll try to find out a way to share with everyone. I really appreciate you are taking time to attend this training. Yeah, I hope this is useful for all of you.
Yeah,
You
yeah.
can find the list of email IDs from the mail list that was pushed to everyone for this invite.
Okay, that's great. Sounds great. And please provide the feedback so that we can improve these sessions. Okay.
One
Thank you,
request,
everyone.
Ravi. Could you please conduct the advanced class by end of December or Jan, because this holiday season is the best too.
We'll be on track also if you do it.
Yeah.
Yeah, I can do that. There is no issue. Let me know. I mean, what works for everyone, and we can conduct another session. No issues. Okay.
Thank you very much.
Sure, Ravi. Thank you for your time. Thanks.
Okay. Have a nice day, everyone. Thank you. Bye.
Thank you, Ravi. Have a good day. Bye.